Welcome to Chemistry Clubhouse. Today we're going to talk about half-life problems. Let's take a look at the first problem. Osmium-182 has a half-life of 21.5 hours. How many grams of a 10-gram sample would have decayed after 64.5 hours? So the first thing to do is write down everything you know. So we know that our parent isotope, in this case, has a half-life is equal to 21.5 hours. All right, we know the sample size, 100% sample size. So the sample equals 10.0 grams. And that represents 100%. If the sample is decayed for 64.5 hours, that means the time. So that's the time, and that's a total. And that equals 64.5 hours. Okay, now let's look at what we have. We have total time, and we have a half-life. So we know that a half-life is how long it takes to decay a radioactive isotope in half. So half of the amount of time it takes for half of the isotope to decay in half. Well, we have 10 grams. So in other words, what that's saying is that 10 grams is going to decay to 5 grams in 21.5 hours. And then that 5 grams is going to decay to 2.5 grams in another 21.5 hours. All right, and that's where we get that graph. All right, so in that graph, we know that if we start off at percent parent and we look at half-lives, at the first half-life, we are going to go from 100% down to 50%. And then at the second half-life, so that's 1 and then 2, the second half-life, we're going to go down to 25. And then at the third, we'll go to 12.5. And at the fourth, we'll go to 6.25, and so on and so forth until we go down almost to 0. All right, and that is considered our half-life curve. All right, so let's see. We've gone 64.5 hours. So our math is we're going to take our total time, 64.5 hours, and we're going to divide it by the 21.5 hours per half-life. And what does that give us? So that says 64.5 divided by 21.5, and that is 3 half-lives. Okay, so as you can see over here, this is 1 half-life, this is 2 half-lives, and this is 3 half-lives. So what that tells us is that we're going to have 12.5% of the parent remaining. Okay, so it says how many grams of a 10-gram sample would have decayed after 64.5 hours. So if 12.5 remains, we can look at this and go 12.5 equals 0.125 in a decimal. And then we can take that 0.125 and times it by 10 grams, because that's my sample, and that will equal 1.25 grams of parent left. Well, how much of it is decayed? Well, that's going to be 10 grams minus 1.25 grams, which equals 8.75 grams has decayed. All right, so that's the first problem. That's when you're taking time and turning it into half-lives, and then using the percentage of the half-lives to figure out how much is left. Let's take a look at the second problem. After 24 days, 2 grams of an original 128.0 gram sample remain. What is the half-life of this sample? All right, so let's write down everything we know. So we know time equals 24 days. Grams, so the total mass equals 128.0. So this represents 100%. And then the mass, so that would be your initial. And then your mass final would equal 2.0 grams. So basically what we're looking at that graph, again, we start way up here, and that would be our 100%, which is 128 grams, 0.0 grams. And then this is going to go all the way down to somewhere down here, which is going to be 2.0 grams, which represents some percentage. Okay, so we need to figure out where that half-life is, because this whole time, this entire time, is 24 hours. Okay, now we know for a fact 128 divided by 2 is 64. So we know after that first half-life, we're sitting here at 64 grams. Now we could just cut it in half and half and half and figure it out, but that just is more work than we need to do. So let's make it easier. We're going to take our final, which is 2.0 grams, divided by the total, or the part divided by whole. Again, that's all a percentage is. Part divided by, in this case, a whole. And then we multiply that by 100, and that is going to equal 2 divided by 128, and that is equal to times 100 equals 1.56. Basically 3%. Now again, that's actually one of the numbers. Okay, we know that this is 50%. All right, and then if we just look at our graph, we know that it goes 100, down to 50, down to 25, down to 12.5, down to 6.25, down to 3.125, down to 1.5625, which is basically 1.563. All right, so that ends up being 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, 5 half-lives, and 6 half-lives. So these two are representing the same thing. Over 24 hours, 6 half-lives have occurred. So the question is, what is 1 half-life? We just have to do basic math. For every 24 hours, 6 half-lives have occurred, which means we have 4 hours per half-life. And we are done with the problem. All right, again, the key to half-lives is to just look and see what you have. Are you having to figure out percentages? Are you having to figure out half-lives? Are you having to figure out time? It's just working backwards and forwards and using this half-life curve and measuring where does it fall in the curve. Now, these worked out really well because, again, in these cases, they were perfect half-lives. If they're not perfect half-lives, then we just read it off the graph. All right, I hope this helps. Please try some additional practice problems, and I hope you understand half-lives better. Bye-bye.